So what it is, it can help you find side lengths and angle measures. And, like the law of sines, it does not require a right triangle. So for any type of triangle, if you want to find a side length or an angle measure, the law of cosines is one way to do that. So your second thought might be, well, if I know law of sines and it does the same thing, why do I need law of cosines? And the answer to that is, law of cosine works for different given information. So side, side is not a condition that would work for law of sines. Try to plug in 3 side lengths into the law of sines formula and see that you would never be able to solve for an angle. And for us, if we have side, 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 law of cosines, you could use one of these 3 formulas. They're all variations of the same thing, so it's not too hard to memorize. I don't know, some years, I think most years we do ask you to memorize it for the quiz and for the test, but there's really not too much to it. We have a meeting today after this class though, so if they may decide what to use the formula sheet, I can't promise that. So don't memorize them yet, but also don't assume that you won't have to memorize them. So it just says if you want to know the angle of A, you could do inverse cosine of b squared plus c squared minus a squared over 2bc. So you need all 3 side lengths. If you wanted to know angle B, notice how stuff's just kind of being rearranged. It would be a squared plus b squared minus c squared minus b squared over 2ac. And if you wanted to know angle C, you could do inverse cosine of a squared plus b squared minus c squared over 2ab. So as far as memorizing them, like if you're trying to find angle A, B, or C, notice how that's what's being subtracted and squared at the end. And if you're trying to find A is the one length not in the denominator. If you're trying to find angle B, it's the one length not in the denominator, etc. There's a lot of pattern there. It's really like you memorize one formula and you just memorize what's different about the others. So that's one unique thing about law of cosines, is it just lets you input different information. The other condition for law of cosines is side, angle, side. Now that's kind of similar to side, side, angle, in that you have 2 side lengths and 1 angle, but what angle you have is different. In side, side, angle, it's not the included angle. In side, angle, side, it is the included angle. It's the angle between the 2 side lengths. And that would be those 2. Same thing, 3 variations of the same thing. So you have to know 2 lengths, and you have to know the angle in between them. So if you knew length B and C, you would need to know angle A. If you knew length A and C, you would need to know angle B. If you knew lengths A and B, you would need to know angle C. Okay, the one I really want to point out to you is the bottom one. So if I covered up half of this bottom formula, where have you seen that before? The Pythagorean theorem, right? A squared plus b squared equals c squared. But the Pythagorean theorem only works in right triangles. This works on all triangles. So what happens if it was a right triangle? If C was 90 degrees, what's the cosine of 90? Cosine of 90 is what? Right, so if it was a right triangle, then this just goes away anyway, so you end up with the Pythagorean theorem. So Pythagorean theorem only works in right triangles. This works in all triangles. Okay, so on the back page, I have a question where we will use a variation of each of these. Just a quick start here. You can see where someone else has done the work. So it's really this easy, since there's no ambiguous case. You don't have to worry about the numbers really making sense. It doesn't get tricky like that. There's no possibilities of being 2 triangles or more. You're going to get one unique triangle. These are ways that you prove triangle congruence in a geometry course. So it guarantees one unique triangle. So if you had these 2 lengths and the included angle, you could find this length. So you can see someone wrote down a formula to find the side lengths. They plugged in the values that they had. did some arithmetic, got their answer. So the calculator, the arithmetic part should be pretty easy, and then that's it. That works. That tells you that side length would have to be 7.632. Nothing more, nothing less. Okay. And then over here, they used it to find some angle measures. So looks like here they found angle alpha, just a Greek symbol. And so here's the formula. They plug in the correct values. I gave them the cosine of the angle, so you need to be careful to do inverse cosine of that to get the actual angle. Then I did the same thing for angle beta. And just a different Greek symbol. So here's a formula that would find angle B, or angle beta. They plug the numbers in, as the formula said. I gave them the cosine of that angle, so inverse cosine of that gave them how big that angle was. Okay, I'm going to go one step further than that. I'm going to say, well, they found two of the angles. Let's find out what it would look like if we wanted to find the third angle. So if I wanted to find this angle, I'm going to call it C. I don't remember that Greek letter. Maybe. Let's just look at this. I'm going to refer to it as C. So if I wanted to find angle C, I could take A squared. A squared plus B squared minus C squared over 2AB. And all of this should be a number between -1 and 1, otherwise it doesn't make sense. And not that we're trying to trick you that way, it just means we wrote down something wrong. But I'm going to want to know the inverse cosine of that anyway. And if you're not careful with how you type this in the calculator, it won't give you the right information. A big fraction there. You need to make a habit out of putting parentheses around your whole numerator and parentheses around your whole denominator. Otherwise, it's going to do a different order of operations than you're expecting. Okay, and we will be in degree mode for this whole section. So just do that. Calculator there. Alright, so I do that, and then it tells me it's about 44.758 degrees. So 44.758 degrees. I don't have to question it. I don't have to question if there's a second possibility. As long as I really knew the formula and I plugged in everything quickly and used my calculator quickly, then nothing else can go wrong. Okay, so why do you think I maybe wanted to find that third angle? Other than just practice. Alright, so now I can check. Like, if all I cared about was that last angle, of course the quickest way to find it would have been just subtracting the two given to me and making sure they add up to one angle, right? But with this, I can test and see is their angle plus their other angle plus what I think the third angle. There's a little bit of a rounding difference. But I can test it's supposed to be 180 degrees, so if I did the law of cosines correctly, that third angle should be 180. So that's why I would do that sometimes, even though it's not completely necessary. Okay, so that is the law of cosines. Really, two formulas, and actually, if you really cared to solve this for cosine of A, cosine of B, or cosine of C, you would get that. So really, it's one formula written in two different formats so that you could quickly find an angle or find a side. And so you need to know when to use them. Side works, side angle side works. If you're finding a side length, your work looks like this. If you're finding an angle, your work looks like that. Okay. One other thing we sneak into this section, and then we'll practice one of each of these from beginning to end before I have you practicing. just like section 6.1, we gave you an area formula. In section 6.2, we want you to know one more area formula. So let's review what you should have done on today's quiz. Or, I guess, all the way back to geometry. Area of a triangle is 1/2 base times height. And then in 6.1, we said, well, the base could be side A, side B, or side C. The base is relative. It can be any side you want it to be. But the height, the length of the height is not usually given to you. So with some trig and some subtotal equations, we can always solve for the height. Now, depending on what you call the base, will change what you think the height is. But it could be 1/2 these two lengths times the angle in between them. That's the side and the side. It could be 1/2 those two lengths, which would make this be the angle in between them. Or it could be those two lengths times the side of A, because A is the angle in between them. That's good. That's a quick way to find the area of a triangle if you have side and side. I would say most of the time you're going to have this. ACT is going to give you that. But this is a very famous formula, and honestly I would not be surprised to see it on the ACT test. Heron's formula allows you to find the area of a triangle if you have all three sides. So this formula says you can find the area of a triangle by doing the square root of S minus A, A is one of the lengths, times S minus B, the rule of another length, times S minus C, where C is the third length. So that's what your next question should be. S is where you add up all three lengths, and you divide by, what would you guess you divide by? Why do a lot of people think it's going to be 3? Okay, so I do like an average, right? Okay, but it's not an average. You divide by 2 because S stands for semi-perimeter. So perimeter, add up all the side lengths. Semi means half. Like a semicircle is half a circle. So I'm pointing that out to you because it's easy to just assume it would be divided by 3. But it's actually divided by 2. Okay, and then that works for any triangle. You know all three lengths, you find S with this, and then you take the square root of S times S minus the first length times S minus the second length times S minus the third length, and then you're going to be area of your triangle. So very, very, very complex. Especially if you do any like graph contrast stuff. ACT is usually okay, so let's actually practice this a couple times. I'm not sure why I made this first question in the back, but I did. I used to teach a bunch of geometry, and so I was probably trying to remind you of something from geometry. In my first period class on Friday, we went ahead and just plugged these numbers straight into the log cosines. And then we got that angle A was 0 degrees. So why do you think angle A is 0 degrees? A and B, if you added them up, they're not. Well, right now they're equal to C, right? But they have to be greater. Right. But if you're trying to make a triangle and one of your angles is 180 degrees, it's not going to make much of a triangle, right? Yeah, it just doesn't work. So to help you, I hope you remember that property from geometry. But if you don't, just imagine these three lengths. If I gave you a stick that was 10 meters, and then I gave you another stick that was 3 meters, and then finally a third stick that was 13 meters, do you see how you could make a triangle out of those? These would have to be connected, and then they would have to lay straight on top of this. And if they're all on top of each other, then you're not getting much of a triangle. So, It's not meant to be tricky. It's just that if you plug it in, you get 0. So it forces you to think about why. So that's not a good one for the formula. Number 2 is a good one for the formula. I've got side, side, and an angle. So you may at first think, okay, great, this is going to be law of sines. But it's not really side-side angle. It's just the order that the information is given to you. If you sketch yourself a triangle, and I'm not going to sketch this anywhere near the scale because I'm saying this is 105 degrees. And you can see that doesn't make sense. But I didn't really have side-side angle. I have side-angle-side. Big difference. Side-side angle is law of sines, and in the ambiguous case, you have to be very careful with what you have. Side angle side is law of cosines, and you don't have to be too concerned with it. It should just work. So, let's say I wanted to find a side length, like C. Well, the formula says it would be the square root of a squared plus b squared, which is almost Pythagorean theorem, but it's minus 2ab cosine C. And don't worry about memorizing the formula. I will tell you if you have to next class. So here's the length of A, here's the length of B, here's the length of A again, here's the length of B again, and here's angle C. So if you want to find side C, you have to know its opposite angle C, similar to the law of sines. Now you can say that this is C squared equals all of this stuff, and then just do the square root at the end. I like to do it at the beginning though, so that I tend to forget that if I don't. So if I type it in just like it looks, let's see, is about 137.241. Okay, and then I would suggest that you store that in for C, because you will need that value again later. So you're going around that. No. Hit the store button. Store button. And then type in the other C. So now anytime I say C, it knows it's not a rounded amount, it's actually keeping up with that whole thing. Okay. We also need to find angles A and angle B. So if I do 2 of them, I have to subtract them and get them from 180. And honestly, now I do have enough information. I could do side-side angles and do law of sines. So if you really love law of sines, you could finish the question that way. But since that's the ambiguous case, law of cosines is going to be a lot easier. A will be the inverse cosine of b squared plus c squared minus a squared over 2bc. Plug in b here and here. Plug in c here and here. And I think that's stored in the calculator. And subtract a squared there. And this one's a little harder to put in your calculator because again, if you don't put parentheses, it thinks you want something different. So this is definitely one thing you need to focus on in this hand. But short of that, what it says is does not need to be questioned unless, of course, it does. That's about 37.75. And I'm not going to write out to angle B. If you really just need that answer, if you don't mind doing it quick, take 180 minus this angle to find the third angle. That's perfectly fine. But I want you to also see if you know log cosines, you take your time to memorize that formula. It doesn't take you very long to have angle b. It would be inverse cosine of a squared plus c squared minus b squared over 2 times a times c okay, so that's not as quick as just subtracting from 180, but it's also not that long if you really know the formula and you're proficient with copying and calculating. I'll admit, first period on Friday when I did it, I thought I may have done something wrong because these are so close to each other. But I have several different things that I could change. I could see, do all three angles add up to 180? And they do. So that tells me I must be doing log cosines correctly. Otherwise, that wouldn't have very unlikely that would have happened. So the biggest side opposite the biggest angle. It's the smallest side opposite the smallest angle. And when you really look at that, that makes more sense. Side B is 86, and side A is 87. So these lengths are almost the same, which means these angles should be almost the same. That's why they're so close. So all of that makes sense. And then different numbers, but other than that, it never really gets any harder. Finding the side length or finding an angle, as long as you know the formulas, you just have to very short about it. Questions you want to ask about number 2? Anybody seen this before? No, this time. Well, I think it was maybe March in the ACT prep class. I know that they had a question about log cosines. So I'm assuming that's because the teacher had seen it in a practice test or an release test or something, but I don't follow it quite that closely. If you're in ACT practice, you must be likely to see it. Okay, and then the one other thing we sneak in is area when given side to side. Heron's formula. So Heron's formula says area of any triangle will be the square root of s times s minus a times s minus b times s minus c. Easy formula to remember. As long as you remember s is semi-perimeter, so perimeter divided in half. A semicircle is half a circle, semi-perimeter is half a perimeter. Okay, so here's the 3 lengths in this question. Add it up. You might want to write it down. Yeah. Yeah, that does not sound good. That should be under the square root. I wonder how many years we've had that on. Yeah, it's being set on your thing here. This should be the square root of s, not s square root. So make sure that you write down how I'm computing s, adding up the lengths dividing by 2. This is another place where it's nice to be able to store. So here's s. So I'm going to have to write out 23.54 times. So the area will be s times s minus the first length times s minus the second length times s minus the third length. area, so it should be square roots. Very easy formula to apply. Probably something that they should teach you in geometry. So this is easy enough, and it's very useful. Alright, questions about Heron's formula?